Okay, so let's just get started with this system design mock. Do you want to give a quick introduction for yourself?
Yeah, sure. Hey guys, my name is Matthew, and I am a new grad currently stuck in application hell. So hopefully these mock interviews will help me with my future interviews. And actually, I believe this is my third time doing a mock interview on here. The first time was I did like a leak code question. Second time was system design, and today will also be system design.
I think so. Yeah. Welcome back. Welcome back to the stream. Great. So let's get right into this problem. Then no more time to dilly dally. I'll give it. I'll give back a bit of time at the end there, so we don't. So we still have the full hour.
Okay. Yeah,
Okay, great.
thank you.
So yeah, no worries. So today's problem, we're going to be designing a web crawler. Okay, so this is going to be a system, and I'd like you to be able to essentially process a set of URLs. So a user can submit, this is a URLs that you process in the background, and the user will be able to submit random English words like search terms. Okay, and you need to be able to return relevant relevant snippets, websites that you've seen that you've crawled that essentially overlap in the search terms with the user's prompt.
Okay, okay. I think I got it. Um, I have heard I've heard about web crawls before, but I'm not sure I'm 100% clear what they are. But from what I
Mm-hmm.
understand, web crawlers, they are things that search like websites on the internet, like in to collect data on those web pages for the purposes of like search engines and stuff like that.
That's a good way to put it,
Um,
right? So we're essentially trying to make the backend for a primitive search engine. Okay, and so you need to design the crawler service, which goes out and explores all the URLs. We can assume that there's a set of URLs, and then you can explore the URLs in those URLs, like, on those pages and whatnot. You can explore all of those and
mhm.
produce a some systems, produce some data which allows users to essentially search, right? So given that data, I want to be able to service a customer request, like a user request. The request will consist of an English word, okay, like some search term
Mhm.
English word, what it may be, and you need
Yeah.
to some come up with some list of URLs for the user to look at.
Okay, so I guess the input to this kind of like web crawler would be a list. Would it be a list of URLs or?
Well, the web crawler itself wouldn't have an input; it would just work continuously in the background.
Okay, so we're not actually giving it any input, but it's just like doing its own thing.
Yeah, well, we might have like an input, like a blacklist of URLs, like you should not visit these, but for
Oh,
the most
okay.
part, we can assume that there's no input; it just visits everything. Okay, just to keep it relatively simple. Yeah.
Okay, and then like once, say like our web crawler is on a specific web page, like
Mm-hmm.
what things are like what kind of data is it collecting?
So we can assume that it looks at the HTML and it finds all the links, right? And then it goes
Hmm.
and explores those links if that's necessary.
Okay, okay. Okay, and I assume like the purpose for this web crawler would be to eventually like design it would be like as part of like a search engine, right? Is that safe to assume?
Yeah, yeah. So once you crawl these links and you determine, what words lead to what links, essentially, right? Or what words on what page, right? So essentially, in this link, what words are there, and therefore the inverse on this. If for these words, what link should we be looking at? Um, from that, we should be able to serve user requests, which are word inputs.
I see, I see.
Mm-hmm.
Okay, so I'm just trying to like come up with some functional requirements based on what we've been talking about. It doesn't take an input, so I guess trying to find a way to word this. So I guess I'm just like write what comes to my mind. So it would search web pages. Um, yeah, search web pages. Is it like there's no like order that it searches in? It's just searching like random web pages.
Yeah, the order we don't need to worry about. So we can
Okay, search web
assume,
pages
yeah, so we can assume that
randomly.
the crawler is implemented correctly by someone else already.
Okay, so it just searches web pages like in a random order, and yeah, okay, visits.
Right. So we're right. Just to be clear again, right? We're trying to the crawler. The goal of it is to generate data. The data is words to links, words to pages.
Oh, so it's like, is it like mapping words, like certain like search terms, and then to web pages
Yes.
kind of thing? Okay, okay, where visits web pages randomly and uh maps search terms to them. Um, so that's what it does. Are there any other functional requirements?
Well, the function. So that's one aspect, right? And the second aspect is that there's going to be a backend, which serves a
Hmm.
web page, right? Okay, let's be a bit more specific. Users need to be able to submit words and receive a list of pages.
Okay, that's the second one. User submitted search terms should return a list of web pages that in theory are relevant to those search terms, right?
Yes. Yes.
Um, okay, so those are the two functional requirements of this web crawler. Uh,
We can start with those for now. Yeah.
okay, and then for non-functional, um, let me think here.
What sort of non-functionals are
Do
we thinking
we?
about?
Yeah, yeah, I'm thinking about like consistency because like obviously
Mm-hmm.
it'll take time for the web crawler to crawl through like all the pages of the internet. Like
Mm-hmm.
so, when a user searches for a term, like the web crawler might not have mapped that search term to like the appropriate web pages yet, or might not have come up with like the optimal quote unquote mapping yet. So, is it fine to in that case either like not return anything in the case of like if the web crawler hasn't like created a mapping from that search term to relevant web pages.
Sure. Yeah.
Okay, so I guess in that case, would it be safe to say that eventual consistency is okay?
Yeah. Eventual consistency is mandatory.
Consistency. Okay. Okay. Yeah, I'm just trying to think. Is for some reason this is kind of difficult because like this is a there's like not really a user that's directly involved in the web crawler.
Yep. So
I
we're going to
think
be
just
designing.
moving.
So let's think about two separate services. Okay. So
Okay.
let's think about the crawler, right? So there's gonna be two services. There's the user facing one, and then a
Yeah, yeah.
separate one which is the crawler. Okay.
Okay, so
Let's
on
pick one.
the
Let's pick one and focus on that first.
okay, so I guess in that case, is it okay if I focus on the user facing side first?
Sure.
Oh, in that case, should I like create a separate list of functional and non-functional requirements or
We can just extend onto this one. That's fine.
extend onto this one? Okay.
Yeah.
So for the user facing side, like they're obviously yeah, so the second functional requirement would be relevant there. And for the user facing side, a non-functional requirement could be In terms of availability, we always want we always want the system to return something, right, when the user submits search term, or is it okay if um, like how available do we want this to be?
Yeah, we want to prioritize availability for this one,
Okay.
for the user facing service.
What else? I guess scalability is always implicit in these things because
That would
like
be
we,
ideal.
we we would expect like a lot of users to be using our system.
Hmm.
In terms of other things, um,
That's fine for the non-function requirements for now.
okay, okay, cool. Yeah. Okay. And thinking about like some resource estimation things. How many users are do we expect to use our this like search engine, I guess, every day?
Let's do a
Lightweight.
lightweight version one of this calculation, because I don't think that will matter too much for us. But
Okay,
for
let's
the
just
sake of,
say
go ahead.
uh 10, 10 million users. Is that
Sure.
okay? And then one thing I want to know is how many like how many searches is each user performing a day?
I think instead of
Uh,
framing this as a user variable, let's just say there are 400 requests per second to the service.
okay, sure. 400 requests per second. So that means but that's actually not that much. For only 400 requests per second, and we have 10 million daily active users.
We can ignore the number of daily active users. The users
Oh,
don't
okay,
actually matter.
okay,
Yeah.
sure. Yeah, so requests per second. So that means like requests per second. I think that will give me some kind of indication of like how many web servers we need to handle these requests. I think I was researching some numbers earlier, which told me that like you can configure web servers to handle like up to 50,000, actually up to like 100,000 requests per second. But if we're only expecting 400 requests per second, then
Mm-hmm.
we don't really need to worry too much about that.
Yep.
Okay, cool. So in thinking in terms of like APIs on the user side, I guess that when a user searches for some search terms, they expect a just going off of functional requirement number two. A user submits a search string,
Mm-hmm.
and what they should expect to get back is a list of links to web pages, right?
Yeah, yeah. List of web pages. That's right. Yeah.
Okay, so I guess we can call this API just search, um,
Yeah, that's fine.
and then it takes in a search string, and then it returns list of URLs. And does this list of URLs need to be? I'm assuming the answer is yes, but the list of URL needs to be like ranked in any way.
No, any page rank is not in scope.
Oh, okay, okay, I see.
Yeah, the
Yeah,
implementation is always correct. We're just designing the architecture here.
okay. So that's for the search API. In terms of user on the user side, I don't think would be any other APIs because usually there's like one API per functional requirement.
Hmm.
Um, okay, and then but then there's functional requirement number one, which the web pages randomly visits web pages randomly and maps search pages to them.
Can we just
I'm just
before we move on to the
thinking,
crawler, can we just sketch out a quick diagram for the user side of the API or the architecture?
oh, okay, okay,
Yeah,
sure. Okay, I'm just gonna use like boxes,
boxes are cool with
and
me.
this is gonna be like a user. Wait, how do I add text to
There's an
this?
A button at the top there. It's number 8.
Oh, I see. Oh,
You need to draw like sketch out a rectangle with it. I think. Um,
oh.
what is this supposed to say?
So we say like a user or
Oh,
client.
it's because this your text box is in front of it. Here you go. Now you can type on it. There you go.
Wait, for some reason I still can't type. Oh, wait, no, I can type on it now. Yeah, okay, cool. Okay, so I think yeah, this is a user, and then let me think here.
That's a good start.
Yeah.
User
So I
touches.
know there's because of the scalability thing, there's gonna be we're gonna expect like lots of users, so it makes sense to have like a load balancer in between our users and then our web servers.
Do we need load balancers? If you previously mentioned that web servers can one web server can serve 400 requests per second.
Oh, right. No, I just kind of like going by like the what we need in regular system. But if we, yeah, no, that's true. If we're only having like 400 requests per second, then literally just one web server is enough to handle is enough to fulfill our requirements. But is always a chance that our one web server like goes down.
That's
So I
up to you.
think
We can
it's
we can
still a
just
good
proceed
idea
with
to have.
whatever you feel like for now. Yeah, this is not the focus. I was just questioning that.
Okay. But yeah, I think it's still a good idea to have like more than one web server, you know. Um, try to copy. Okay, there we go. Copied.
Nice.
And there'll still be like a I guess in this case it's not really a load balancer, but just like a thing that randomly chooses like which web server that user request goes to. Okay, and then after this part, which is not the most interesting part, I'm thinking, okay, there needs to be a couple of components here. So I believe there needs to be like the a couple of services, let's just say. There's gonna be a web crawler service which performs which just crawls the web in the background. And then I'm thinking it will store like these like mappings from like search term to relevant links in some kind of database. And then there will also be some kind of search service, which is responsible for like the logic of turning search terms into a list of links.
Okay. Yep.
So I'm just gonna represent those as boxes for now. And then there's also going to be a web crawler service. And then there's going to be a database. Uh, and I think one interesting thing is like how like tables in this database are going to look like.
Mm-hmm.
Like I was reading about like how search engines work like a while ago, and from what I remember, like there's this thing called like a reverse index
Mm-hmm. Yep.
where like um, search terms are associated with like various um, they're associated with a number of attributes such as um, like documents like which documents that search term appears in, and then like how many times that appears, how many times that search term appears in that document, and then like various other things.
Yep.
So
We can
maybe we
just
could do something similar to that for our database.
Yeah, we can assume that
Uh,
the database exposes a reverse index API.
okay, should I just roughly draw out like what the table should look like?
Yeah, if you can just tell me like
Thanks.
the primary like what type of database this is, if it's gonna be SQL, NoSQL, and the primary keys as well as the fields you might have in some tables. Yeah.
Okay. Um, Okay, so the big question is SQL or NoSQL for this use case. Benefits of using NoSQL are horizontal scalability, which is useful in the case where like we want to we have like lots of data and we want to like partition that data into like various database
Mm-hmm.
instances. It's it's a lot harder to scale SQL databases. Um, yeah, I'm thinking like we would need a lot of data in our database, right? Because like the internet is a gigantic place. Or one thing I forgot to clarify is like, is this web crawler crawling the entire internet, or is it just crawling like some small subset of the internet? Like,
For now, just some subset. Like so, in this case, we might start it off on an internal, like internal website, but the details
internal
don't
web.
matter that much. It like that's a scaling question. The data it produces will be the same regardless, right? So for example, some of those websites have that search bar. You can assume it's something like that for now.
Okay, okay. Yeah, so I think I want to use like a NoSQL database because
Mm-hmm.
I think that the data could still be like could potentially be very large. Uh, I mean the volume of data.
Yeah. Okay. That's fine.
Um, so that, yeah, in terms of like what a table in this database would look like, is there like a way I can draw a table here?
Oh, don't think so. But you can just use a text block and just write lines.
Okay, sure. Uh, Yeah, so I'm just writing this right beside the database. So I'm thinking a table in this database could be like, hmm, what would be a good name for this table? I'm storing like, yeah, well, okay, a row in this table would be like search term. It would be search term. And then I would say like a list of, yeah, a list of document IDs, which corresponds to like documents where this search term appears. Uh, I don't know what the syntax I should be using.
That's
List
okay.
of,
I'm assuming the first one's a primary key and everything else is just values in the row.
yeah.
Okay,
So
and
list
this
of
is an
document
ID, the second one?
ID. Oh yeah, so it's a list of document IDs.
Okay.
And then there'll also be like um, maybe one thing that could be useful is how many times that search term appears in that document. So list of frequencies. I don't know. There's probably some other useful attributes
We can come back to
that
that.
I'm not thinking of.
Yeah, we can come back to that. That's not a big deal.
Okay, okay. So for now, like this is what the table could look like.
Okay.
Okay, now going back to the architecture of the entire system. Um, okay, so I'm thinking there needs to be like two separate phases to the system, like an offline phase and an online phase. The offline phase being when the web crawler actually does like its uh, crawling in the background.
Mm-hmm.
The reason I think we should separate these two phases is because they're both pretty resource intensive, right? And we don't want to use like the same. We don't want like shared responsibility. Um, like what I'm trying to say is we don't want the same components to be sharing these two like different responsibilities.
Uh,
Uh,
which component are you referring to exactly?
like I'm referring to like searching and crawling as like
Searching
the
and
two
crawling.
different things.
Right, and you're saying they're resource intensive. In what ways are they intensive? Like what why is that
Oh well, okay.
why
On
should we
the
separate it because it's intensive?
Yeah, well, so on the user facing side, there's gonna be like lots of users sending like lots of search requests to our system, and then like on the web crawler side, um, it's gonna be like doing a lot of work too in visiting lots of websites and then extracting data from those websites and then putting that in the database. Is those two things are not really they're not really related either. So I think different things should handle that.
Yeah, well, in other words, we're I'm not sure what your proposal would be, but if you're saying you can't run them at the same time, then
Oh no,
users.
I'm thinking there should be running like a like asynchronously.
Yeah, the web server. I mean, the web crawler will be running asynchronously, right? It's
Yeah,
always
yeah,
it's
yeah.
always running.
Yes, yes.
Yes.
Yeah, so I'm thinking like how to like order these components. Okay.
The database needs to provide where the search service is the read path of the database,
Yeah.
and the web crawler service can be the write path of the database.
Yeah, so both these things are talking to the database.
Yeah. What's this big box for?
Oh, this is like this is like the representing like the back end of
Okay.
our system, isn't it? Yeah, yeah, the back end is gonna be consisting of the search service and the web crawler service. And these arrows are just saying, okay, these web servers are gonna be talking to the back end.
Sure. Yeah.
So I'm just gonna say, okay, this is the back end. Okay, sorry, I'm slightly lost here. I think what would make sense is like just go through a flow of functional requirement number one.
Okay. Sure.
Okay, so the user searches for some search term. I'm just gonna give an example like um what would be a search term like uh um Canucks game. Canucks game. Okay, and then that search term gets sent as a request to our web server, which the web server not that important in this case, but it'll handle like requests like validation and any kind of like authentication, which we're not worried about. But then it will send this request to our backend, which will hit our search service. And then I think what will go on in this search service is that it will like tokenize our search string into words, right? So before our search string was just like Canucks game, then it'll get turned into something like a list of tokens, like Canucks, and then as one token, and then game is like another token, right?
Mm-hmm.
And then this tokenized version of our search term will get it will look for the search term the tokens Canucks and game in our database.
Mm-hmm.
And then according to the table in our database, for each search term, there's a list of document IDs. Um, oh, so I think one thing I forgot to do is we need a document. We need a document table,
Right.
right?
Yep.
Because if we have document ID, then we also need document. Uh, so think of what that would look like. So document, and I don't think table is the best way to name this. This is like index, I guess, reverse. I just call it index, and then documents. Thinking what would go here, it would be obviously documents ID. Um, and then it will be like it'll be the content of that web page. So it'll be like some HTML stuff. Yeah, it'll definitely be like the HTML of that web page.
I believe the second functional requirement is just a list of web pages.
Oh, okay. Thanks for thanks for reminding me because in that case, that's a lot easier to just say that. Okay, it's just a URL. Then it doesn't have to be like the HTML,
Yeah.
right? Yeah. Okay. Yeah. Thanks for reminding me. Uh, yeah. So it'll be document ID, and then it'll be like URL. Yeah, as the second table here. Right. So back to our search service. So once it tokenizes the search string into a list of tokens, it will like look in the database for each search term, and then return a list of it'll return a list of URLs based on if the search term appears in that document,
Mm-hmm.
right? And then maybe it might take into account like the um, how frequently that search term occurs, and then maybe it can gets fed to like some ranking algorithm. But I don't think I need to worry about that, right?
That's right.
Okay, so then for now, it just returns a list of okay, just going back here. It returns a list of URLs. So this list of tokens and then just becomes a like list of URLs like I don't know www dot nhl.com/Canucks as like one
Mm-hmm.
example, and then maybe like www dot youtube.com/Canucks, and then like so on and so forth. Dot dot dot. Yeah, so I'm just to draw an arrow here from there to there.
Okay. So one thing we
So
want
I
to spend a bit of time clarifying here is this backend box, right?
mhm.
Um, how are we planning to run these two? Like, are they going to be there's going to be one host with a search service and one host with a web crawler service?
Yes. So yeah, for like separation of concerns, I think we'd have like one host running the search service,
Mm-hmm.
and then one host running the web crawler service asynchronously.
Okay. And
And I know I didn't talk that much about the web crawler service yet,
yeah.
but I think the big idea is it will visit just like web pages at random, take the HTML, and then just like figure out like what keywords are there in that document. Like the reason I say keywords is because there are like some words that are generally not really important to search engines, like filler words like and space period.
Yeah.
So I think there'll be like some kind of intelligent way that the web crawler will determine like what is a keyword, what is not. And then so from that document, it'll extract all the keywords, right? And then it will populate our database. That's
What is yeah.
roughly what's going on.
Yeah, that makes sense to me. But one thing, and we're not going to be focused on the web crawler too much. I think that's a bit out of scope here. Um, one thing I noticed is that you did have you have a load balancer for the web servers, and so, but you have one host for the search service. Is this implying that uh, the web server was going to be the bottleneck here?
Oh, right, because yeah, in my in my diagram, I've literally just drawn one search service. Um, yeah, I'm trying to think if we need one host or if more hosts are needed. Um, well, keeping in mind that we only have 400 requests per second,
Mm-hmm.
so in theory, like in terms of the like computational load, one server would be enough. Uh,
Yeah.
but obviously, the probability that the search service goes down due to like power outage or like like I don't know like a meteor hits our data center and then it goes down. Like obviously, we would need to replicate this search service across multiple data centers. That reminds me of one thing is that our yeah is that we need to replicate this search service across multiple data centers across the world, right? Because
Yeah.
I'm assuming like our end users are going to be located across the world. So
Mm-hmm.
it wouldn't make sense to just place the search service in like North America because if a user from Europe wants to search something, that would take forever.
Okay.
So I'm thinking in terms of replication, like we would need to replicate like we need to replicate like this entire system across different geographical locations. So this is what I've drawn here. It's just what's going to be the case for like one single geographical location. And even in one geographical location, there still needs to be like replication.
How is
Um,
the um like everything here is going to be per geographic location?
let me think here. No, I think I was quick to answer there, but let me just think.
Yeah.
What needs to be replicated per geographical location is what I'm thinking. Um, I'm thinking um, the database itself needs to be replicated. There needs to be like a yeah, this definitely needs to be replicated. So I'm thinking that there could be a cluster of like origin, let's just say origin databases, which has like which is like the source of truth for basically everything. Like it contains the most up to date data,
Right. Yeah.
right? So
Well,
basically, that's the database that our web crawler service writes to first.
which one is the crawler writing to? Is there going to be a one crawler
Uh,
per region as well, or what?
I think there could be the more let me think about this. Well, the more crawlers we have, the quicker we can like crawl, right? So,
Mm-hmm.
and I don't think um the work of one crawler like interferes with the work of another crawler. They're doing work that is like highly scalable. So
Mm-hmm.
we could have like multiple crawlers.
Okay.
Yeah. But the thing that the web crawler would write to first would be the origin like databases, and then those databases they would write to the databases, or there would be like some other service which would take the data from the origin databases, and then they would write to the databases in other geographical locations.
I see. So for a
Yeah.
crawler in a geographic location, we're gonna write to the global one, and then the global will replicate it to the regional ones.
Yeah, that's
Okay.
my first thought about that.
Okay. Um, that's that. We can pause on that for now. And the search service. I want to talk about the search service briefly now for today. The search service. Um, one of those per region. Is that what we said?
Yes,
Okay, one of those per region. And what database will it be reading from?
it will be reading from the database that's closest to it. Um,
Uh huh.
yeah, I don't think it will not be the origin database.
I see. Okay. And you mentioned earlier that one of the reasons you picked NoSQL, NoSQL is that it's better scaling. What kind of scaling considerations are there to be made for reading in terms of the search service? Right. I mean, in terms, I'm because a web crawler you're saying is not writing to a local database or to the geographic local database.
Yeah.
Um, so the only traction with the local database is the search service essentially. What kind of scaling considerations are there for that service?
Um, right, because I'm assuming there's gonna be a lot more like quote unquote reads than writes.
Mhm.
with the read being like a search, right? And with the write being like um, like mapping some search term to some links.
Sure, yeah.
If it's if they're going to be a more reads than writes, then I think it would make sense to have a lot of like read replicas of our database in order to balance the load.
What's the downside of having more read replicas?
Um, the downside of having lots of read replicas is that it'll take time for the changes to propagate, or like the writes to propagate to all those read replicas.
Mm-hmm.
But I think since we said we're okay with eventual consistency, it's not too big of an issue.
Okay. Okay. That's
I think
yeah.
like if it were an issue, like if eventual consistency were an issue though, um, then there would be a problem if if like our if it takes forever to propagate our rights to the read replicas.
Yeah, that's I mean, yeah, that would be an issue with the replication in general, right? If that
Yeah.
was an issue. But that's a very difficult problem to solve. So, even today on Google, it is a case that everything you see is not immediately updated and it is eventually consistent there too.
Yeah. Like one thing I've noticed like on YouTube is um when I'm like looking on a really like popular channel
Mhm.
and I know they've like scheduled a video to be released at some particular time and I refresh that channel's page on exactly that time, but I don't see it yet. Like
Yeah.
maybe it'll be like 5 minutes later and then that video will appear, but it will have already had like 100 views.
Mhm.
So I
Yeah.
think yeah, that's also a real life case of eventual consistency.
That's true, for sure. Okay, let's pause this here. There's a bit more stuff to talk about in this one, so wanted a bit of time for that. Um, overall, I think I mean this was definitely a step up in difficulty compared to the previous one, which was design pastebin. Um,
Yeah, it was definitely.
it was more of a logical step up and not like a random thing that that is like way more difficult. Like what I mean by that is that the two like there's two services here, right? That like the first thing to recognize for this kind of problem is that there's actually two services. I think that one got you a bit confused for quite a while at the beginning. Um, and I think that definitely cost you some time. But I think once you recognize that this is two services, things do simplify quite a bit, especially if you just pick one of them and just make one of them like front to back, right? Like the problem really opened up a lot once we decided to just move forward with implementing the user flow. And then given that
Hmm.
architecture, we can see how we can fit in the web crawler. Now, why is this appropriate? Well, the two reasons here that I want to point out is the first thing is that we're not really focused too much on the performance, right? And what that implies is that we're not looking for the most scalable thing. We're not looking for some very elegant design in that matter. We're looking for a particular design that can actually just work and serve their purpose, right? That's the first thing to recognize. And I think that's important to recognize because if you ever get an interview and performance is not really something the word we're talking about, you shouldn't be thinking about that very much.
Hmm.
Okay, and so given that that the focus is just making a correct design, what are the things we have to think about, right? The user flow is actually exactly the same thing as like just anything else you've done in the past, right? Web server handling some requests, and at this time there's a database, right? There's a search service in between. Now there's a couple ways you can model the search service, right? The most common way in this case is just to assume that the database provides a reverse index that you can query, and so it would
Hmm.
be in that case it would be literally the same. Now, more pragmatically is that now what you've done here is you've made a search service that's also very correct. In fact, that's actually a bit better because you can scale that separately from the data. So that's actually a bit better. But he didn't mention that, so you don't get points for that, unfortunately. But the search service is a good idea because uh, there's kind of two things you're going to the database for, right? And the search service allows for a couple things that are a bit more, let's say, convenient. The first thing is the search service, which you haven't really done in the database. The search service can maintain its own database or table of popular searches, right?
Oh, like some sort of cache.
Yeah, like a cache. Now databases have
Oh,
cache too, but one thing you can do that's separate from databases is you can make the caches more geographically specific, like geographically local, right? For example, if you're saying that you can have different web servers doing different things, different web servers can query, like a web server one can query specifically search service one. Well, maybe web server one is serving Vancouver. Then maybe Canucks is cached a bit more, right? So
oh,
you can
okay. Yeah,
have
no,
more
that
local
is that
prioritization.
is something I didn't think about when I went off on that tangent of like replicating stuff across like different geographical regions.
Yeah,
But
but
yeah, it
it's
would make
important.
sense that Canucks is searched more in like Canada than in like China.
Yeah, exactly. So that is one thing which a search service can provide, which you didn't mention, right? So in your design,
Mhm.
actually, there's no benefit having a search service at all because that thing is just tied to the database. So there's no points there essentially. The database itself is fine. One thing I will say is, if we're doing database schemas, okay, well, first thing is that it's pretty good justification to say we're using NoSQL, better sharding, better horizontal scaling, boom, done, call it a day. That's fine. Um, you know, I think one thing you could definitely spend a bit of time talking about is exactly what type of replication protocol or what replication standard we're using. For example, right?
Yeah.
I'll give you a couple examples. You said there's a one global database that has that all the web crawlers write to. Okay, here's the thing. That's like if you're doing that, there needs to be a bit of, let's say, like you have to be a bit more explicit about how the scaling works. So, for example, the way you said it, which is you have one database who does it, that's not, you can't scale that, right? You can't scale one database horizontally. Then the web crawlers need to determine where they go. So you need to be specific in saying we have a global shard of databases or collection databases, and these collectively work together to know. For example, if a web crawler finds a link that has a word that starts with C, that goes to the C global database, for example. So that's something you can be a bit more explicit on in terms of what you're
Oh
talking
yeah,
about.
like sharding. Yeah, sharding is like one thing that I should have said because I think you touched on that last time where
Yeah,
uh if you have like user controlled like IDs, then you can shard by that ID, and then that will help with horizontal scaling. Yeah, yeah,
yeah, like that's something that you have to mention because if you're just saying, oh, my choice is to use NoSQL because it's better for horizontal scaling, and you don't horizontal scale anything, then that's unjustified. Okay,
oh shit. Yeah.
so that's the thing there, and then let me check my other note. Blah blah blah. That's fine. That's fine. That was whatever. Okay, right, and then yeah, this little thing tangent you wanted to, so you had this document table as well, right? You went a little tangent about that, right? You forgot the function requirement is that we're just serving the list of web pages, right? We don't need to worry about
Oh
that.
yeah, yeah,
So just
not the
be
web
cognizant of that,
pages,
like
but
whenever you're working
yeah,
through a problem, just always remind yourself what the requirement is, so you don't waste any time on that, right?
yeah.
Um, okay, but that part, the user part is pretty straightforward. Nothing too special there. The web crawler service is a bit more. That's the new part essentially. For an interview like this, I was basically hoping we would get to the user part pretty quickly because it's basically the same thing you've done before. The web crawler part is a bit more interesting. The main kind of insight on this thing is what you said, which is correct, which is to run it asynchronously, run it separately. Um, the web crawler does not need to be regionalized, right? Like one thing to keep in note is that you can access, for all intents and purposes, you can access all web pages from anywhere in the world, right? Like
Yeah.
for example, you can access YouTube in every and so YouTube not a good example. You can access most of the websites from any other country, from any other location. Why is that significant? Well, what's the downside? The downside is your latency is higher. How much higher? Okay, how much higher? It's a ping, right? The worst ping you can get on planet Earth is like 250 milliseconds,
Oh
right?
really?
Yeah, that's about it. Unless the like for in terms of like network ping. Now the web server could be slower, right? But the web server being slow is independent of your location, so it's still going to be about 250 milliseconds overall. Okay. So what I'm saying is what I'm actually getting at is your web crawler. having a higher latency for crawling web pages doesn't affect the outcome of the crawl, right? Because your replication latency, or how eventual, quote unquote, you'll be consistent, is far longer than 250 milliseconds. So what that means is that you can centralize all your crawlers into a separate location that doesn't depend on being coupled with your search service. So in other words, your web crawler does not need to be geographically locked. Okay. So that
Hmm.
is a key piece of insight, which is quite important. The reason that's important is because then you don't need to have a quote unquote global source of truth. Your source of truth is just tied to wherever all your web crawlers are, like in the same location, right? That way you don't need to make as much of you don't need to make as many network calls. Like your network calls are much faster that way. Okay. So that is one of the differences there. Now you were actually had good intuition in saying that okay, we can have a global table database, sorry, which or global set of databases which web crawlers exclusively write to, and we can eventually replicate those out to all the regional databases, all the regional read-only indices, right? That's actually quite good. But if you actually think about it, when you originally proposed that, there was no reason, like there was no benefit in having a quote unquote global source of truth, right? Like it was kind of silly if you think about it that you would have in your case. Let me get my pen out. In your case, you would have whatever. Like you had your web crawler tied in the same backend as your search service, but the web crawler is writing to a different database in a different region,
Oh, okay, that
and then
that
this
makes
database will
sense
have to
now.
get replicated back, right? So this this
Yeah.
this this design here has a flaw in that sense. So
Yeah,
so
this web crawler
this
service is
network call,
completely
yes, yes, this should be
independent of
there
like
should
what's
be
going on here in
that's
this
right.
backend.
That's right. This should be completely independent, and over here you can have like 10 of these, times 10 or whatever. You can scale these as many as you want, right? And of course, one thing else, which we didn't get to, right? So this is we didn't get to this. But if you have more time, what we could have talked about is some of the more input and outputs of the web crawler service, right? So at the beginning, I told you to save time. Basically, I said we can assume that this is all correct. We don't need to worry about that. But in an interview, they might ask you to think a bit more about the web crawler, right? So for example, one of the um, key things to talk about for web crawlers are it's like you can imagine web crawlers is a big breadth first search, right? You go to a page, it has like 10 links or whatever,
Yeah,
right? Average pages have some number of links, usually quite a few links, right? And so,
yeah.
uh, you can't just say okay, web crawler start at google.com and go crawl every link. That won't work, right? It'll run out of memory, right? I can't store all the to do links in its memory, right? So one thing I'll give you a quick little overview, but in your own time, I want you to also think about some more details about how the web crawler can run. Okay, because you can imagine, right? A web crawler can't just start somewhere and just finish all of the links it can reach. That's not possible. Okay, so one thing you can think about is having a separate service to manage the to dos. Okay, so let me just quickly just you know what I want you.
Oh
I want
yeah, because um like different web crawlers they wouldn't know if the page they're crawling has already been crawled before without like this separate thing telling it
exactly.
like it has already been visited.
Yeah, so you need to have a way to kind
Yeah.
of track that. And also one thing you can imagine is that depending on the size, so you have a service here, right? So this is a crawler scheduling service, right? It's called a scheduling service, right? This service is responsible for for initializing web crawlers. So for example, web crawlers, and this, by the way, this is another table database that's local to the entire web. So this entire thing also is one region. Okay, this is a logical region. Okay,
Okay.
so a web crawler service, it says okay, I go to this link, it has 10 links, I add all 10. Okay, first of all, is what I do is I add it to my own memory. Okay, now my memory is getting full. I can't add any more to my memory. Then what I'll
Hmm.
do is I will add all the new links to the service. Okay, so we add to all service. Okay, and the service says, oh, I have like a billion links that people have been adding to me. That what that means is all my web crawlers instances are all full. Like they can't handle anymore. And so what I need to do is I need to spawn more services. I need to spawn more web crawlers. So this is crawler 2, right? Crawler 3. So this scheduling service spawns all these sub processes based on the demand of the number of links there are, right? And one more thing which you didn't touch on, which I didn't really give a functional requirement for, so I don't think it's that important. But what this opens the door to is it opens up for what you over here call frequency, but more relevant is called like the like some ranking function, right? So for example,
Yeah.
let's say we add Facebook.com to the next crawl. Okay, our crawler scheduling service says, oh, Facebook.com. Okay, before I schedule it, let me see how popular Facebook.com is, right? Because if it's a popular website, we want to index it ASAP, right?
Hmm.
And so it goes to some table that's like Google, they call it page rank. We can call it our rank, okay, right, whatever. Okay, this is our arbitrary ranking system.
Yeah.
How do you spell rank? RANK. Okay, and it says, oh, Facebook is very high ranked. I'm gonna immediately spin up a service to run Facebook.com. Okay, Facebook.com. Okay, if it's a different link, like maybe I don't know, some like local Craigslist link bullshit, it goes to this thing and says, oh, this rank is very low. It's like rank, I don't know, 10 million. We don't care about that. Then it'll just toss that shit in the trash and just not worry about it, right? So now with this, so the nuance here is that by providing a scheduling service, it can react to the demand to scale up and scale down, and it can react to demand by changing the threshold needed to start scheduling, right? So this is one of the ways you can do load balancing is by just essentially only prioritizing high rank links. Okay. So this is a key component here, which I think a lot of people would be expecting for a web crawler to succeed, because the insight, right, is that a web crawler, as it visits more and more links, the branch factor explodes to infinity, and so there's no way that an individual crawler is able to is able to essentially do all the work itself. Great. Okay. Let me just click on my notes. You can think about any questions you have. I'm gonna go look at my notes right now. Oh no, no. I think this is all the stuff I had. The biggest one was search service being localized so it can provide itself its own cache, and the crawler service, which we didn't really get to, but the crawler being by itself so that it can essentially be a bit more logical, help itself scale. Um, and otherwise, yeah. So and one more thing I'll point out is that, yeah, of course, we had the 400 requests per second. I know that's low. That's on purpose. The purpose here was not to see. There's two things here. The first thing is that the user side is not the focus of this design. That's basically what this meant. Okay, so when you see something that's really kind of low like that, you should just check. Oh, what's the focus? What are we trying to do? Are we trying to basically like are we just trying to only type like crawler? That should be something which helps your priority. Okay, because for something that's 400 requests per second, you can serve that just on a single computer. That's not that important, right? So use the kind of performance requirement there to inform your priority for solving some part of the problem.
Hmm. Hmm.
Okay. Anything else for you on your side?
Yeah, just like yeah, thanks. First of all, like thanks for giving this mock interview. I definitely do need the practice. But yeah, when I first heard like that this was gonna be a web crawler system design, I had read about I had read about web crawlers like some time ago somewhere, and I knew that there were like some like um like big brained um like ranking algorithms
Mm-hmm.
that could be used, and I don't know like if it would be like how much detail into like the actual ranking algorithm would be expected for like a interview.
Um,
How much detail?
yeah, the ranking algorithm, which is known as PageRank,
Yeah.
is usually not in scope for system design. That's just not that relevant for system design for two reasons. Because, well, the first reason is obviously because um, that is a Google trade secret. Another one is
Oh,
because
I know people always talk about like the YouTube search algorithm. Like content creators always talking about like how they wanna optimize their
yeah,
videos for like
yeah,
the search algorithm. They always use like air quotes, but
yeah,
they don't
yeah.
actually mention because like no one knows what the actual search
No one knows
algorithm
what
is.
it is. If you knew, you would be making trillions of dollars. But the main thing is just that that's not system design, because and similar to here, right? Like we're not saying
Okay.
implement the search service, which has the these documents, definitions and whatnot. We're not telling them to implement the web crawler with a for loop here. Like
Okay.
that sort of stuff is more on the algorithmic side, if anything, and not really on
Yeah.
the system design side.
So
So
in the case of system design, it would just be okay then to just say, okay, there are just some like ranking service which does the ranking for us, like draw a box for that, and then just
yeah, yeah,
move on. Like we have to go into
yeah. For us
into
in
that,
this
right?
case, it started off being just assuming that the uh, the the database has a reverse index, which is actually a
Okay.
very good terminology. That was exactly correct, right? And then you
Yeah.
put in the search service, which is even more correct, but you didn't justify it, so you got no points for that.
Yeah.
So
Yeah.
that those would be the components which had the page rank algorithm on it, essentially. Yeah.
Okay. I think this is like a point of inexperience on my end, but when I just heard that we were going to be designing a web crawler today, my brain immediately, like my primitive brain, just immediately jumped to, holy shit, this is gonna be like a really big brain, like leak code hard, like designing a like page rank algorithm.
Mm-hmm.
But now I've learned that okay, it's just system design. We're not too worried about algorithms as we are about like designing like the different
That's right. That's right.
components and how they work together and how they fulfill the uh, functional and non-functional requirements.
That's right.
Yeah, okay.
Okay. Yeah, that sounds like that was informative. Any other questions on your side before we end it?
um, okay, this is like a more general question, but like, other than like participating in these mock interviews, like well, what other practical ways are there of like improving on system design interviews?
System design interviews are popular because you need to have experience to know the systems. I would say the most effective way to prepare for them in terms of a new grad level interview is to study common systems and figure out what makes these systems succeed. And one common way you can
Yeah.
test yourself in knowing and how well you know a system is by arbitrarily adding restrictions. So, for example, go find you won't know the actual crawling design, but you go find some Medium article. There are probably like trillions of those. Some Medium article of a page rank or Google search, just like Google search, and given their design, ask yourself first of all, read it, understand it, and ask yourself, what if this happened? What would be the bottleneck? Or what if we impose this restriction? Now what would be the issue? One common one for a lot of these things is by changing the shape of the input. So, for example, an example of changing the shape of input for a search algorithm would be, or a search system, sorry, not algorithm, search system would be if suddenly there was a celebrity and certain search terms were very, very popular. Okay, in
Oh,
that
okay.
case, what would happen, right? Or if you're, or for example, in this case, we can say, oh, what if in this case we support now there's a large influx of people speaking a different language in Canada, right? Now, how would that impact your system, right? So you can test yourself and your knowledge on a given system by figuring out what other systems' weak points are, and you can do that by adding these restrictions and seeing what happens. So
Okay. Yeah, and then I
that's a way to
guess like
practice.
once I add those arbitrary systems and then come up with my own answer of how the system would need to change to adjust for those changes, then maybe just like ask like ChatGPT the same answer and then just compare answers, right?
I don't know. I don't know how good ChatGPT is that, so I can't say. But
Okay.
one thing I will say is just that a lot of it does come down to like some of it is practice, and you won't really know the right answer all the times. But that will give you at least a way, like a thing to research and learn about.
Yeah.
So it gives you a direction, right?
I
Unlike
guess like these things are like system design stuff is I guess something that you would think about like on a daily basis when you're like actually when you're actually a software engineer, right?
yeah, I
Uh,
mean I think about it pretty often because I make a lot of stuff, but I also know some people who don't want to think about it very often, don't
oh,
need to as well. Like it's sort of up to you. Um,
yeah. I mean, like for most of like I would say almost all the internships that I've done, like I've only really been thinking at the code slash application level, not really thinking too much about like the system, like the architecture level. But
yeah, I mean,
I think
I think
that's
as you get
one
more and
thing
more
that you can only
senior,
really get experience with actual practice.
Yeah, that's just how it is. But as you get more senior, there'll be more and more expectation for you to be able to understand these things. So it'll come with time as well.
Mm-hmm.
Hmm. All right. Anything else?
No, yeah, I think I definitely learned a lot today. Yeah, thanks for uh going like way over time. And this is also like the third interview of the day, right? So you also must be kind of exhausted by now too, right?
Yeah, it's average Sunday evening. So take care, everyone else. Then, thank you for your time.